20 grams of solute of molar mass 200 grams is dissolved in 50 grams of solvent. Raises the boiling point from 227 degrees centigrade to 231 degrees centigrade, and freezing point is lowered from -23 to -28 degrees centigrade. What is the ratio of enthalpies of vaporization and fusion of the solvent? So the data given is weight of solute, grams of solute, that is 20 grams, and molecular weight, molar mass of the solute is also given, that is 200 grams per mole, and weight of the solvent, capital W, that is 50 grams. And also given that the boiling point delta TB is 231 minus 227. This is the elevation in boiling point that comes out to be 4 degrees and is expressed in terms of Celsius. Similarly, the freezing point is decreased from -23 to -28. So the depression delta TF is nothing but -23 degrees to -28 degrees. In other words, 5 degrees. So this is the depression in freezing point. This is the elevation in boiling point. But what is asked? Ratio of enthalpy of vaporization to fusion. So enthalpy of vaporization, say LV, by enthalpy of fusion, LF, is how much? So this is what is asked. So we need to get a relation between enthalpy of vaporization and fusion with elevation in boiling and depression in freezing points, and this given data of solute mass, molecular mass, and solvent mass. We know that delta TB is equal to KB into M, delta TF is equal to KF into M. Thereby, on dividing with equation 1 with equation 2, we get delta TB by delta TF is equal to KB by KF. Further, we have delta TB is equal to RTB square by 1000 LV, equation 3. And similarly, delta TF is equal to RTF square by 1000 LF. So this is relation 4. And by taking the ratio of 3 to 4, we get delta TB by delta TF is equal to RTB square by 1000 LV into 1000 LF by RTF square. So this R gets cancelled, 1000 get cancelled, and we are left over with TB square into LF by TF square into LV, equation 5. And therefore, between these two relations, here we have delta TB by delta TF is equal to KB by KF. Here once again we have delta TB by delta TF. So we can equate delta TB by delta TF is equal to TB square into LF by TF square into LV. But what is that we want? Since we want the enthalpy of vaporization divided by enthalpy of fusion, therefore LV by LF is equal to TB square by TF square into delta TF by delta TB. So this is what we are asked to find, LV by LF. And we already know delta TB by delta TF is 4 by 5 from these two. Therefore, LV by LF, that is the ratio of enthalpy of vaporization to enthalpy of fusion, is equal to TB square. What is TB square? Square of the boiling point. But what is the boiling point of the solvent given? We are given 227 degrees centigrade. The boiling point is raised to 231. In other words, the normal boiling point is 227 degrees centigrade. That is 227 plus 273. That comes out to be 500 Kelvin temperature. So therefore, TB square can be written as 500 into 500 by TF square. What is TF? The freezing point -23 degrees centigrade is further depressed to -28. In other words, the freezing point of the solvent is -23 degrees centigrade. In other words, 273 minus 23. How much? 250 Kelvin temperature. So 250 into 250. And delta TF by delta TB. Delta TF 5 we have. Delta TB 4. So 5 by 4. That is 5 by 4. So therefore, now on simplifying, 500 by 250, 2 times, 500 by 250, 2 times, 2 into 2, 4, and 4, that comes out to be 5. So thus, the ratio of enthalpy of vaporization to fusion is 5. Therefore, the answers are given as 0.2 wrong, 2.5 wrong, 5 is the answer. So C is right. It's not 3.2. D is wrong.